this lesson, we're going to be reading this scenario, and then we're going to write an exponential growth or an exponential decay function. And then we're also going to sketch a graph to represent the situation. So first thing we have to do is read the scenario and try to determine, are we doing growth or decay? So let's first read it. It says you have a scientist researching certain bacteria that have been found recently in the large animal cages at a local zoo. He starts with 200 bacteria that he intends to grow and study. He determines that every hour the number of bacteria increases by 25%. So it's increasing. So we're definitely dealing with growth. So we're going to go with our exponential growth function. So in order to write an exponential growth function, what we're going to do is we're going to substitute in our A value and our R value. The A value is your starting amount. Your R value is your growth, the percent of increase or decrease, and you're going to divide it by 100. So I'm going to do 25% divided by 100, which gives me 0.25. Okay, so to write my function, I'm just going to substitute in these two numbers for A and R, and I'll have Y is equal to my starting amount, 200, 1 plus my 0.25 to the x power. So that's going to be my function. And now we just need to graph this. So you can use Desmos to graph it, sketch a graph. Let's go ahead and look and see what this looks like on Desmos. We already know it's starting at 200, so that's going to be my starting amount. So I just have to figure out after a certain number of years what my function is going to be worth. So I can either graph it and then sketch it, or you could use Desmos and substitute in different values for x. So we'll substitute in our x as our time. So it says it's every hour it's increasing by 25%. So this would be after 3 hours, this is after 6 hours, this is after 9 hours, 12 hours, 15 and 18 hours. So let's go ahead and get some key points here. We'll use Desmos to do that. And we can substitute in different values. So if I substitute in 3, then my y is 390.625. Which is about right here. If I substitute the 6, so after 6 hours, I've got 762.9. I'm going to go ahead and round that up to 763. So 6, we're going to go up to 763, and we're estimating a little bit where that point is. If I get 9 hours, let's do 9 hours. Got 1490.11. So 9 hours, I've got 1490, so about right here. Let's do one more. We'll do 12 hours. You got 2,910. You could round that to 0.4. All right, and the bacteria is going to be growing at an exponential rate. You can see it's going to continue to increase. The last thing you're supposed to do is estimate the number of hours he should let the bacteria grow if he wants it to have no more than 2,000 bacteria. So if we look at our graph, the 2,000 is, it reaches 2,000 at approximately 11, it looks like 11 hours. So we can substitute that in right here, and we see that it's 2,328. So that's too much. So let's try a little less than that, like maybe 10 hours. Whoops, sorry about that. My eraser is too big. We'll try 10 hours and see what that estimate gives us, since 11 was too big. We got 10 hours, and that's less than 2,000. So it looks like it's going to be somewhere between 10 and 11 hours. Um, 11 was over 2,000, and then 10 was under 2,000. So it'll have 2,000 somewhere between 10 and 11 hours.